Okay, for the next talk, it's my pleasure to present you Jeffrey Berkeley. Jeffrey Berkeley is the founder, chairman, and CEO of My Technology, who is both a pioneer and leader in robotic surgery simulation. He is an expert in robotic surgery simulation and real-time element modeling. Assistant professor in industrial engineering at the University of Washington. He received a PhD in mechanical engineering and is MS in biomedical engineering. Thank you for your coming. I appreciate it. Thank you.
Thank you. It's a real honor to be here. I'm going to warn you, I'm running on just a couple hours of sleep, so if I seem to doze off, feel free to throw something at me, wake me up, get me back in it. No, I want to thank you for being here. It's such a prestigious society. I think the institution here is older than the town I come from. So anyways, I just had to throw a little cartoon in here because one of our challenges is battling perceptions. And when you talk robots, everybody seems to think that the robot does all the work, that it's automated, such as what we're seeing in the scene here. There's also perceptions of what some surgeons and general public believes that simulation can offer. So what I'd like to do is sort of put everything in perspective, talk about some of the limitations, opportunities, and where simulation really can take us. So I want to start off with a study. Some of you may have heard about it. It was done by the Institute of Medicine, a study called To Err is Human in 1999, where they noted that there was no cohesive effort to improve healthcare, and they called for the creation of a Center for Patient Safety inside the United States. The reason for this is, with their research, they reported that not only were we wasting somewhere between 17 and 29 billion a year due to preventable medical errors, but somewhere between 44,000 to 98,000 Americans were dying every year. So you would think this is a bit of a wake-up call. Now, it's really hard to get your head around these numbers, so let's put it in perspective this way. This is like 5 jumbo jets crashing every single week. That's how many deaths we're looking at. So you can imagine in the aviation industry, if this many jumbo jets were going down, nobody would fly. So if everybody knew about the medical errors that were taking place in medicine, I think people would be rather hesitant to go to a hospital. And with social media and the way the public is becoming much more aware of what's happening, this is not something that's going to be swept under the rug for quite a while. This is a study I like to point out because part of what we're talking about is how do we measure ourselves. So James Butch Rosser did a study where he took 150 self-proclaimed experts in laparoscopic surgery, and he asked them to do what you would consider a common task. This would be tie an intercorporeal knot in a box trainer. He found that 82% of them could not tie a knot within 10 minutes. How are you an expert if you cannot tie an intercorporeal knot? So this begs the question. You might think you're an expert, but are you? So as Butch likes to say, are you the best of all times or just a legend in your own mind? So maybe measuring our surgeons is a good way to go if we can find a way to do it objectively. So certainly the report in 1999 should be a wake-up call. So another report 10 years later called To Err is Human, to Delay is Deadly. Yes, measures were taken, but did anything happen? Yes, it did. It got worse. If anything, the estimates were that medical errors were increasing by about 1% each year. So this is an equivalent of, on average, about 100,000 preventable deaths each year, reaching 1 million deaths. And as the authors quote, this statistic by all logic is conservative. So, and here we are, 10 years later, still no national entity to comprehensively track patient safety. So simulation was certainly looked at as something that could be utilized to address the training issue, to objectively measure performance and decide and try to make some determinations on when somebody is ready for surgery. This is a whole bunch of the simulators that came out between 1987 and 2003. Actually, in this very room is somebody that's credited for creating one of the very first procedure training task simulators, and that's Dr. Rick Satava. He was also very instrumental when he became part of DARPA, getting a lot of these companies funded. The sad truth is that many of these companies have died out, especially at the dot-com bubble. Part of this is because the companies overpromised. If you look at this, almost every one of these is a procedure simulator. The question now is, could we really do procedure simulation? Can we really do complete immersive VR simulation now to do procedures? And that's an important question. Are we trying to jump right to the final task, or what are the steps along the way? Usually when you suture, you start with a box trainer, maybe a pig's foot. You don't go right to suturing people or create a simulator to suture people. There's steps along the way. So can surgery simulation make an impact? I certainly believe so. It is a very, very young industry. There's only a few of us that have survived since the early 2000s. Mimic was founded in 2001. Sadly enough, that makes us the oldest pure digital surgery simulation company in the United States. I know it's like being the skinniest kid at fat camp, I guess. But at any rate, we are getting improvements. Computers are giving us more processing power. Graphics capabilities are drastically improving thanks to the video game industry. And we have better modeling. And as a result of the improved fidelity of the simulators, we're starting to see patient safety centers pop up all over the place, all over the world, or simulation centers. And by evidence of us being here today, there's momentum building for using simulation testing for privileging and credentialing. I think this slide sort of sums up some of the dangers of surgery simulation. It's a little bit of a fuzzy picture, but what you have some crocodiles on the side of the road and a sign that says, "Hikers and bikers, move to the side of the road when a vehicle approaches." Probably not very good instruction and probably dangerous to the trainee. So this is something, maybe, I say this tongue in cheek, but if you are going to create a simulator and you believe that you can apply so much force to tissue, or that tissue is going to stretch so much, and all of a sudden they get into the surgery and they find out, whoa, this isn't the case. You could do damage to the patient. So we have to be very, very careful about working within the abilities of what we can accurately model. Or we might end up like the passenger who's told to go to the side of the road here. So the components of simulation, just creating them are somewhat of a challenge. For hardware, you usually need a visual display. You need motion tracking to track your instruments. And in some cases, or in many cases, force feedback. These are solved problems, except the force feedback part is very, very expensive. Typically, if you have force feedback in a simulator, your simulation costs usually run into the hundreds of thousands in the United States. So this is because we only have so many customers. When we're talking, if we're lucky, a couple hundred customers for a simulator, if you're doing really well, thousands. We're fortunate enough with the Da Vinci simulation platform we've created. If you take the simulation platform that runs on the Da Vinci and then the DV trainer, which is what you see off to the left, there's about 1,600 in circulation. That's by far the greatest installation base we have for a simulator. 1,600 doesn't seem like a lot of customers to me, but this is why we have to deal with such high cost. Now, where we start running short is the realistic tissue mechanic modeling. What you're seeing is what I believe is state-of-the-art simulation. This is what we're doing at Mimic, but frankly, we have a long way to go. You see, these are single organs. They're relatively simplistic tasks. And what we've talked a lot about, especially Rick Satava talked about a performance assessment. Without performance assessment, how do you know you're doing something wrong? How do you know you're going to be that student that says, well, I didn't know I was doing something wrong because you didn't tell me? Well, the simulator can do that for you without having valuable proctor time spent overlooking a trainee when really the proctor might want to be in surgery. So getting a little bit more into the challenges is really when you get to multiple bodies in a surgical environment, multiple tissue bodies connected by fascia. It's very, very complex. and this thing makes it very difficult. So you should, if you're going to do procedure simulation, you take the lowest hanging fruit, do the simplistic anatomical environments. I would say that there is limitations on the basic skills. I still haven't seen anybody that's been able to do dissection well yet and make it look anywhere close to realistic. It's suturing itself. I think ours is pretty good. I don't think it's perfect, but I think many of you have seen suturing simulators out that are not so grand. And then what happens when we're really, let's say we want to do a prostatectomy. Your environment's always changing. You're cutting, you're applying energy. Do we have the graphical capabilities to update your texture maps so that you can actually make it seem like it's realistic? Right now, I would argue we do not have the graphical capabilities to fool anybody into believing surgery simulation is real. And finally, well, we got a lot of problems to solve. I heard the question asked, well, where do we get the money earlier? So let's look at the market overall. The last estimate I looked at, the entire simulation market, and this includes mannequins, is about 790 million. Just over 100 million, and I gotta admit, this is my own personal estimate by some numbers I've seen from various simulation companies, is pure digital simulation. This compares to 3.2 billion for flight simulation and 68 billion for gaming. So let's see where our priorities are. Anyone ever played Grand Theft Auto? In the first 3 hours that this game was released, it made more than the entire surgery simulation industry. And they were up to $1 billion in the first year. And that's just one video game. So a lot of folks ask, well, the video games are so realistic. Why can't simulation be more like that? Well, our problems are very different. We don't have deformation, we don't have cutting, we don't have these kind of things in a video game, and most importantly, video games don't have to be real. There's no consequences to them. So you can see what it takes to make something like this and get these beautiful realistic images. We don't have anything close to that kind of budget. We're lucky if we have $1 million to do just a single simulation exercise. So a lot of people love to make the analogy of flight simulation. Flight simulation is something where we have very well understood fluid dynamics. We can model it pretty darn realistically. I think the best analogy for why flight simulation works, and it was alluded to just a little bit ago, if you take up a real airplane, it's very expensive. Most people will learn to fly, if you're learning to fly a jumbo jet, exclusively on a simulator, and when you take that jumbo jet up for the first time, it's full of passengers. Well, the analogy does apply to robotics. Using a robot's very expensive. On average, it's about $3,000 per surgery just for the tools. And that doesn't include the OR time and everything else involved. Compare that to laparoscopic surgery, where you can take 2 instruments, get a shoebox, a ham hock, and you go start suturing. You've got a very low fidelity, low cost simulator. There is no alternative for robotics but to use the robot unless you have a simulator. So that's why it sort of makes sense to compare for flight simulation. But when you look at the body, you're talking biological structures that are highly nonlinear, inhomogeneous, anisotropic, viscoelastic. A lot of engineering terms to say that this is very, very complex modeling and very, very difficult to do. Now we do have hope. I can't help but throw some of my PhD work. This is a real-time finite element model in the middle. This is made up of, you can imagine, little cubes and tetrahedrons. If we know the material properties, we can simulate those extremely accurately. Put them together like a thing of Legos. Put a texture map on, like we see the bladder over here and the hand to the left. Then you actually have a simulator. At this point in time, this is very computationally intensive. There's still a lot of difficulty managing the boundary conditions. I just want to show you that there is hope. However, right now, most people are really doing video game types of approaches that have no basis in physics or continuum mechanics when they're building their simulators. So let's just get to robotic simulation. So, and I apologize, a little bit of shameless plug for our products, but we began doing surgery simulation for the Da Vinci back in 2003. We started beta testing in 2007. Dr. Hubert was one of our very, very first beta testers, so that's why he had all those wonderful images that I'm almost very embarrassed about of our very early prototypes. But we finally released the product in 2010. It does, of course, use virtual reality to teach you how to use the Da Vinci robot. It may be intuitive surgical, but the robot is not that intuitive. You cannot just get on the robot and immediately start doing surgery. There is a learning curve. The learning curve might be less steep than it would be for laparoscopic surgery, but it still exists and you still have to address it. And then there's performing the basic surgical skills. We've already talked about the cost. When you don't have to use the robot, you don't have the costs associated with it. So you don't waste materials, you don't waste training aids, you don't waste instruments, and you don't waste valuable OR time. Let's also remember there's an access problem. You still need to be able to get to the robot to do training, so if your robot's tied up all day to do surgery, and this goes too if you have a simulator that uses the robot, you can only use it at nights and weekends or when it's not being used for surgery. So there is a reason to get outside of the OR. It's costly. And best yet, we have the performance analysis, something that you do not have if you use the actual robot with dry labs or animals. Your performance analysis is your proctor, which is a little bit subjective at times. So our goal is to increase affordable access to Da Vinci training so that we can encourage utilization, improve surgeon performance, and increase patient safety. Now, and I don't just mean this because I think that the robot is great. Well, I do. But the reason is because I think that let's take hysterectomies. Still, over 50% of them are done in an open fashion. This is not a difficult, minimally invasive procedure, but people don't have the training to address it. So I look at the robot as an enabler to allow minimally invasive surgery and to get people to an expert level faster. We talked about the FRS tasks a little bit earlier, and if the FRS tasks were too easy on the robot does make minimally invasive surgery easier. So I'll try to go through this a little bit quickly. I know I'm probably going to be way over my time here, but the best thing about simulation is we can measure everything in the environment. We can measure the time it takes you to do something, your economy of motion. How smooth are you going from point A to point B? Are you colliding your instruments? Are you dropping needles? Are you moving instruments when you can't see them? Too much stress, are you applying that? Are you misapplying energy? Is there blood loss? There's all sorts of things that we can apply, and we do have the scoring system built in that Rick talked about, where we've measured a bunch of expert surgeons. One standard deviation below gets you to that experienced surgeon level, and that's what gets you the check. But you have to decide what your critical metrics are and pass all of them, and you don't just pass it once. You could get lucky. You have to be able to do it again and again. This is why you have for FLS, pass it twice consecutive and 10 times non-consecutive. Well, our base standard is 5, but the reality is this whole thing is completely customizable. If you want to put in your own surgeon data, you believe your own surgeons perform at a higher level, certainly every hospital is an island of performance, you can do that. You can decide which metrics you think are important. Not all metrics are created equal. You can create a curriculum with 65 plus exercises available. You're not going to become proficient in every single one. Some are going to be better for urologists, some are going to be better for gynecologists, some are good for a new user curriculum, some are better for surgical warm-up and skills retention. It's all customizable, and the best thing is it's all shareable. We have a site called MShare where you can go and you can look at the experience that people have had with simulation, and you can download it and port it right into your simulator, and it automates it for you. There's no standing over a dry lab, marking somebody down as they go, which is expensive. Again, you're in the OR, you're still training with these dry labs in the OR, so you're able to automate the process. We sincerely hope FRS will be something that will be downloadable, and anybody with the simulator is going to be able to download it and train independent of a proctor. Just real quickly on validity, we all know a simulator should be validated. If you can't validate it, it's nothing better than a video game. I just point out that I think the most important ones are construct validity. We got to be able to distinguish experts from novices, but also predictive validity. But this presents a challenge. Predictive validity is expensive. If you're going to track long-term patient results, there's a cost to that. But there are some things we can do. We can measure operative times, blood loss in the OR, so we need to do more of these studies. Every one of these validities has been done for robotic surgery. for robotic simulation. It's actually probably one of the most validated simulators out there. And if anybody wants, this is just a partial list of publications. Dr. Hubert's name's on there probably quite a bit. But I'm going to point out just one predictive validity study that I think is pretty powerful, and this is called the Morristown Protocol. This is where 5 robotic surgeons, expert robotic surgeons, averaging at least 75 cases per year, at the time 28 exercises. So they looked at all the exercises, they picked out 10 that they thought were good for training gynecological surgeons. They also took those 10 and they tested themselves. They made sure that they each did the 10 exercises. They made sure they each did them 5 times minimum. And then they cherry-picked the best results of all the experts. It actually became very challenging even for the experts to pass it. Then they offered up free Da Vinci training if you could pass the simulation protocol first. They ended up recruiting 14 study surgeons. These were board-certified surgeons with 17 and a half years on average of experience. So these surgeons knew the procedure. They just didn't know how to use the robot. But here's the interesting thing. These surgeons spent between 9.7 to 38.2 hours to pass this curriculum. All you had to do was pass it once. Pass the 10 exercises just once and you could move on. This gives you an idea of how much time you have to put into simulation training, something that I'll follow up with. And then they compared this to a control group, was essentially surgeons that were privileged to use the robot, but weren't using the robot more than twice a month. The results were pretty amazing. They found on somebody's very first hysterectomy, they did use the dual console, just to be sure. They had somebody there to watch over them. But they found that the study surgeons were statistically the same as the experts that created the test in terms of time and blood loss. And they even compared reasonably well when it came to the blind video review. Here's the scary part. The control surgeons took 50% longer, statistically had more blood loss, and ranked the worst on the blind video review. So this begs the question, do you want to allow somebody to do robotic surgery without maintaining their skills? Certainly there's a role for simulation there. If we had gone through more of the research papers, I could have, these messages probably would have been clearer, but I want to point out that there's been various people, including Dr. Hubert, that have done studies to try to find out when that learning curve levels off. On some of the easier exercises, it can be around 6 trials until your performance, this is like the pick and place type exercises. But if you want to do your anastomosis, and we're talking without the thread, we're talking just driving the needle, that can be 74 trials. So this can be a real investment of time. Not all metrics are created equal. So every exercise, you got to consider what probably separates the experts from the novices, which metrics have the greatest statistical significance. Trainees learn at different rates. If we're talking, well, first of all, just think about this. If you were I think there's a perception out there for a lot of people, they're going to get on a simulator and use it for an hour or two, and they're going to be good to go. Well, if you were a pilot, do you think you'd only put a couple hours of flight training in before you took a real plane up with yourself? Well, think about that in terms of surgery. If it's you on the table, how many hours would you want your surgeon to train before they do their very first surgery on you? So this is a time commitment, and it's very difficult. Everybody's busy, especially residents and fellows. We have the 80-hour work week. Everybody complains about it, and not to mention, you're not generating revenue if you're not training on patients. That's the sad truth. But is that really the ethical thing to do? So there is a time commitment in getting across this perception that simulation is an expense rather than an investment, and that you do have to put some time in it to actually see these results where you trained it, that you perform at an expert level on your very first case. You got to put some time into it. It's in time and effort. There's certainly some great evidence out there that simulation is very good for surgical warm-up. Tom Linvey in our neck of the woods found that when doing simple ring transfer and some needle driving experts improved right on the robot, right afterwards, improved suturing skills 4-fold. And this was the experts. This wasn't the novices. Experts improved 4-fold from a surgical warm-up using a simulator. And then there's always a question on, well, okay, do I need to use the simulator on the robot itself, because that's the real thing, or can we use an emulator? Well, certainly we can make a simulator that right now is $100,000. If you want to give us $500,000 for it, we can make it exactly like the surgeon console. But the reality is studies have shown that if you take an expert, put them on the skills simulator, which is the one that our same software that runs on the backpack, or you do the DV trainer, the scores are going to differ by as few as 3%. Again, a non-C study. So lots of studies from Dr. Hubert here. So this is something where you may have a Ferrari at home and you may love to drive it. And when you get a rental car, you may not like it because it doesn't drive like your Ferrari, but it still gets you from point A to point B. You have to ask yourself the question, what's the most important? Does it have to be exactly like the robot, or does it get you up the learning curve? So a little bit about where training's going. This is, we're talked about training standards. We already talked about FRS. I'm going to talk about one that goes a little bit before it, and this is RTN. So this is, again, the same concept. You couple simulation like you're seeing at the bottom. These have matching dry labs. You also have this dome where you dock the robot to the dome, and you do the dry lab test on the real thing. But what's interesting about this is they have a great learning, we're building a great learning website where you upload your simulation data so you can compare yourself to the rest of the population. In this case, they have 50 institutions participating so far. Intuitive donated instruments in these pods and dry labs for free. We're trying to find out how to expand that. I doubt they're going to keep giving them away for free, but at least it's a good start. And then better yet, when you do your first surgeries, you get to upload your first surgeries and get blind video review. This RTN network is a robotics training network, is available to everybody. If you looked, if you just Google robotics training network, you can take a look at the site. It's still very much in beta, but it's going to be available to everybody. This is geared towards your residents and fellows. Then you go to FRS. Then what's coming out is, as Rick mentioned, is FRGS. That's when you start getting into surgical tasks. We're still not doing complete procedures, but you are doing actual tasks like anastomosis, things that are more relevant to particular types of surgeries. There's competitive robotics. I'm going to say Dr. Hubert's name again. He's the one who created this. We did a surgical robot competition in Athens, Greece, where what we did is we took surgeons. They would come to the booth and they would basically try to go through trials and get tested. You'd do a couple of exercises, you'd get a score, and you'd have a leaderboard. The top 8 would go to a finals competition, typically done on the skill simulator, on the real robot, so it's head-to-head like you see here. And they'll take a simple task. In this case, it's just something innocuous. You're just stacking blocks and dominoes, and whoever can get the highest within 2 minutes wins. You would be surprised how experienced surgeons will sweat under competition. So why do we want competition? We want people to train beyond proficiency. We want people to get into that expert level. So this is why we need gaming techniques in competition to leverage everyone's, I believe that's from Athens right there, yes? So I believe this is a way we can get people to utilize the simulator, make it fun, and advance their skills at the same time. I've heard this mentioned a bunch of times. We can't just think about the surgeon. We need to think about the team as a whole. There's a lot of ways we can use simulation for the entire team. We've got some efforts where we've created a laparoscopic simulator where the ports are adjustable. You can pretty much match any laparoscopic setup for the assist. This is very different. You don't always operate in a comfortable environment, especially with robotics. You're always twisted around. You might have your manipulator down here for the ureter. It's not a comfortable position. You need to be able to represent that. This was something I just came from a conference where we introduced this simulator for the very first time. It's going to be released this summer. It's going to focus as you as an assist can train individually with a virtual partner. Then you get together with your team. You train. You do your communication. So this way we at least get 2 legs of the tripod. I think there's the rest of the surgical team makes up that third. But this is a way where I think we can move efficiency forward. So I know I've been relatively negative about what about procedures and what do we do here? Well, I do believe there's an intermediate solution until the technology gets good enough so that we can generate quickly realistic environments. What you're seeing here is this is a surgery being performed by Dr. Indebergil. We're using augmented reality. We're taking 3D surgical video. We're overlaying surgical content. And here you can see somebody's just identifying anatomy. And you're actually able to follow along with the surgeon. I can watch a video of Tiger Woods playing golf all day long. I'm not going to be a better golfer. I have to swing the clubs. I need to do what the surgeon is doing. So that's the concept here. You're moving, you're using your instruments. Here you're predicting a retraction in the magnitude and the direction of the retraction. At every step of the surgery, you pause and you predict the next step and you perform it yourself. It doesn't have to be a still. In some cases, it's going to be a running image where you're matching the motions of the surgery. But this is really the way I see a simulation in the short term going. And the reason this is, I think, good is because this is not something that's going to take us a year to do. We plan to be able to turn around a single surgery in a matter of days. So you can imagine if you're giving a live surgery, you can be able to say, in 3 days, you can now download the interactive version of the surgery I just did. This will allow you to be introduced to hundreds of scenarios, not just one. I mean, we're as different on the inside as we are the outside. You need that variability and that exposure. Also, it may be surprising, but it might be hard for certain surgeons to agree on a surgical approach. So take the surgeon you like. Pick the surgeon you want as a mentor. We hope to have a very big library. This is something I think we're actually going to do the very first partial nephrectomy class at the AUA. It's AUA sponsored. It's all going to be digital. It's all going to be virtual. So finally, of course, what we'd like to get to is make the training part of the procedure itself, patient-specific modeling. Take your medical and images, build a model of your patient, do the procedure before, plan that procedure, even make some of this material available to you during the surgery. Well, the good news is it's already being done. CyberKnife, you actually sit down, the surgeon actually is reduced to somebody drawing contours of organs, and then the robot automatically does it. Or if you want to look at something like bone and cartilage, which is actually pretty easy to model now. Even vasculature isn't that hard to model now. The idea of doing patient-specific simulation that becomes part of the clinical tool is something happening now. It's much, much more difficult to model the entire abdominal cavity, but we can get there. So I just wanted to give you a little bit of a glimpse of where simulation is going. We talk about an FRGS and an FR, all the different FR variations. Yes, that's probably might start with augmented video. It might go to full VR, because in full VR you can make up an approach, right? But then eventually this is where we want to be. And that's where I will leave it. And this, by the way, I'm sure you guys have all run across this. This is the scary part. You get kids on here, they have no fear of simulation. They routinely outperform surgeons that are just starting in simulation. So, video games do pay off. So, thank you very much.
Thank you. Thank you, Jeff.
Merci beaucoup.
Please. Let me know, Jeff. It's just a new one presentation just for us, isn't it?
This one?
Yes.
I did it on the plane on the way out here, yes.
Each time I hear you, each time I upgrade my practice, my standard, and my knowledge. Thank you.
Oh, thank you. I appreciate it.
En tant que discutant et pour mener la discussion, j'appelle Xavier Martin.
Merci beaucoup. En fait, on parle de deux choses différentes. D'une part, utiliser un nouvel instrument, et d'autre part, effectuer une intervention chirurgicale. Alors, si on décompose une intervention chirurgicale, les gestes de base et les gestes combinés comme suturer deux tuyaux ou un vaisseau, ça, on le fait avec ces simulateurs de façon extraordinaire et il faut absolument s'en servir. Ensuite, il y a la tactique opératoire, prendre le bon plan, bonne dissection, et ça, on n'arrive pas encore bien à le faire avec les simulateurs. Et je rejoins un peu ce qu'on disait tout à l'heure. On a besoin d'autres modèles, de développer d'autres modèles pour effectuer cette tâche. Donc, on a encore, entre le simulateur et effectivement apprendre une opération, un chemin à parcourir. Et j'ai un commentaire à faire sur les jeux vidéo qu'on nous a montré. Il a été montré par les neurophysiologistes que faire du jeu vidéo, ça améliorait les performances, la reconstruction 3D, et probablement nos enfants seraient capables de passer le FLS bien plus facilement que nous si on commence à un âge tardif. Donc, j'aimerais avoir un commentaire. I have to have a comment from you, where, now, these simulators can help you doing a basic, you can suture, you can do knots, but you cannot do a full operation. So so you explain us that you will have a new, in vivo, like the mentoring that you showed.
Yes.
What is your project from the simulators to the real, surgery? Yeah.
We started working with Dr. Indeberg Gill about a year ago, and we talked to, of course, so we're engineers, so we're not the ones that really needs the ones to decide what content goes in. So we worked with Dr. Gill and Dr. Hung about what they felt was most important messages to get across when they're lecturing on how to do a surgery, and we embedded it. When you actually experience this surgery, you're going to have Dr. Gill's voice guiding you through it, and he will also be reprimanding you in very interesting ways when you make a mistake. So this is sort of an enhanced way of the see one, do one, teach one, except the only limitation is you have to do it exactly like the surgeon does it. You can't take a creative approach. That's where you need the full VR, where you can invent a procedure.
So mentoring is the next step.
Yes, we have
Thank you.
partial nephrectomy in May and hysterectomy in December.
Est-ce qu'il y a des questions? Oui.
Ce n'est pas une question, c'est un commentaire. Je vais être très bref. Mon nom est Georges Lawson. Je viens de Belgique sur invitation du professeur Hubert, mais juste pour apporter un témoignage. Je pense qu'il est important qu'une société savante comme la vôtre ici se saisisse de cette situation pour corriger quelque chose qui est en train de se passer sur le plan européen ou sur le plan mondial. Nous discutons aujourd'hui de la performance qu'il faut atteindre pour pouvoir utiliser le robot en salle d'opération. Mais nous oublions quelque chose d'autre. La performance que nous devons atteindre ou que nous devons aider nos jeunes médecins à atteindre pour pouvoir opérer. Autrement dit, ne pas délivrer la licence de tuer. Puisque aujourd'hui, quand j'ai commencé ma médecine et que je suis dans un laboratoire d'anatomie, on me demande, si je suis tout seul, qui est-ce qui t'engueule, je m'excuse pour le terme, lorsque je fais de la dissection anatomique et qu'il n'y a pas un mentor à côté de moi. Aujourd'hui, il y a de moins en moins de dissection pour apprendre, pour que l'apprenant puisse se saisir de ce qu'il doit faire et mieux le maîtriser. Donc, c'est un problème global. Nous sommes à l'extrémité parce qu'on est aujourd'hui dans le monde de la vitesse. Il faut aller vite, il faut bien apprendre, il faut maîtriser l'instrument, la technologie nouvelle. Mais il y a un amont qui est l'apprentissage de base. Donc, c'est juste un témoignage. Je pense qu'il faut le faire. Je participe au DU de Nancy et je me rends compte que ceux qui y ont participé sont meilleurs lorsqu'ils rentrent dans un bloc opératoire parce que je fais partie de ceux qui font de l'accompagnement pro-intuitif, donc du proctoring. Quand je vais accompagner quelqu'un, un novice qui commence la chirurgie robotique, s'il n'a pas eu un entraînement, il est très mauvais. C'est évident. Donc, il faut absolument que nous fassions quelque chose. Et j'espère qu'aujourd'hui, ce sera la naissance d'un événement où on décidera de que faire. Que coûte une vie pour qu'on décide de comment trouver les moyens de financer ce projet.
Merci.
Ok.
Merci.
Oui, s'il vous plaît. Oui.
Oui.
Oui. Ah oui, déjà, je suis neurochirurgien. Je pense qu'effectivement, nous avons tous besoin de simulateurs pour reformer nos élèves qui ne peuvent plus accéder aux cadavres, qui ne peuvent plus accéder à beaucoup de choses du fait de la judiciarisation de l'acte opératoire. Je suis ancien neurochirurgien militaire, il n'y a plus de guerre. Donc il faut des simulateurs pour que nos jeunes apprennent à opérer. Mais où je suis un petit peu embêté, c'est la robotique. Est-ce que c'est apprendre à utiliser la machine Da Vinci? Je me souviens, en 2001, après l'exploit de Jacques Marescot entre New York et Strasbourg, on avait une réunion au Val-de-Grâce en 2001, en octobre 2001, c'est-à-dire 2 mois après, où nous avions réuni toutes les disciplines utilisant les robots. Et M. Loisan, c'était là. Il y avait les chirurgiens thoraciques, il y avait les chirurgiens cardiaques, il y avait les neurochirurgiens, il y avait les orthopédistes, il y avait tous ceux qui étaient intéressés. Les neurochirurgiens, il n'y a plus de problème. Nous, les robots sont chez nous. Ils définissent les trajectoires, ils simulent les interventions et la robotique est là. Malheureusement, enfin heureusement, l'industriel ne veut pas aller jusqu'au bout, c'est-à-dire enfoncer l'aiguille dans le thalamus. Il laisse encore le chirurgien faire ce geste. Et c'est tout. Donc là, c'est de la robotique. C'est facile en neurochirurgie parce qu'on n'a jamais mis les mains dans le cerveau. On a toujours manipulé. Hein, on n'a jamais mis les mains. Donc, moi, mon rêve, étant neurochirurgien militaire, quand j'étais à cette réunion en octobre 2001, je me dis c'est fabuleux parce que maintenant, le chirurgien pourra rester ici et le robot va opérer en Afghanistan. C'est la même évolution que dans une armée de l'air, car je suis également de l'armée de l'air. Le bombardement à haute distance de la Serbie, un missile est arrivé sur l'ambassade de Chine. Tout le monde a dit attends, on s'excuse et tout. Mais bien sûr, les Chinois étaient en train de capter tous les signaux pour diriger les bombes laser. Bien, mais il y a toujours un pilote dans l'avion, mais ce n'est pas lui qui décide la cible. Il faut que nous passions, avec Jacques Baresco, on en a discuté, lui, il imaginait déjà le chirurgien qui est ici, le robot qui est à Ouagadougou et le robot qui opère. Non, il faut un intermédiaire. Et le meilleur intermédiaire, c'est encore le chirurgien généraliste. Donc nous avions envisagé de donner un complément de compétences, c'est ce qu'on appelle la téléassistance chirurgicale. C'est-à-dire nous avions essayé de mettre à cette époque-là au point une troisième main pilotable à distance ou simuler l'intervention ou prévoir l'intervention à distance et aider à distance. Là, refaire une gestuelle de rapprendre des nœuds.
On va enchaîner sur la présentation suivante, peut-être.
Oui, bon, excusez-moi.
De vous couper parce qu'on a un petit peu de retard sur le programme. Et donc je vais appeler Didier Leger, qui, lui, est directeur général du cabinet d'assurance Midi Risque et qui va nous parler justement de la réalité médico-légale des assurances et innovations thérapeutiques. Donc voilà. Juste un petit mot pour stimuler justement l'intérêt de nos jeunes vis-à-vis des spécialités chirurgicales. On organise par exemple le 22 mars les premières Olympiades de simulation en chirurgie robotique pour les internes en urologie. Ça se fait en association avec Henri Mondor et donc tous les internes pourront se réaliser une compétition entre eux.